This is Kasturi Day. Today, now I'll discuss the water chapter, continue the discussion of the water chapter according to ICSE syllabus class A. So, okay, today I'll start with the solution, suspension, and colloidal solution. Okay, colloid, you can say. So, what are the what is a solution, what is a suspension, what is a colloid? So a solution, it is a homogeneous mixture in which the particle size is less than 10 to the power 10 minus 10 micron. Okay, 10 to the power minus 10 micron. Okay, so it's a homogeneous mixture in which the particle size is very small, which is about 10 to the power minus 10 micron. The solute particles are not visible in it. We cannot see the solute particles. Okay, if for example salt solution, we cannot find the salt particles within the from the solution of the salt particle. Okay, salt solution, that is. Suspension is a heterogeneous mixture in which the solid particles, a little more is the size of the solid particles, and that is about 10 to the power minus 7 micron. Okay, and they are dispersed in a medium, mostly they're liquid medium, and they remain suspended in the medium. For example, chalk in water, mud in water, sand in water. So these particles are visible to us. That's a suspension where we can find the it is a heterogeneous mixture. We can find the solid particles. They are suspended in the liquid medium. Okay, and that is the size of the solid particles is slightly bigger than the solution in the particles of a solution, that is 10 to the power minus 7 micron. Okay, a colloid. Now we come to colloid. A colloid is a homogeneous mixture which look like heterogeneous mixture. It's a homogeneous mixture, but it looks like a heterogeneous mixture in which the particle size, it ranges from 10 to the power minus 10 micron to 10 to the power minus 7 micron. So it's between suspension and solution. Okay, and the particles are dispersed in a continuous medium. For example, milk, blood, smoke, jellies, butter, ink, soap solution, etc. Okay, these particles, they are homogeneous, but they look like heterogeneous because the solid particles, those particles are the size of those particles are between 10 to the power minus 10 micron to 10 to the power minus 7 micron, in between them. Okay, now we come to now we have studied the definition of a solution. What's a solution, what is a suspension, and what is a colloid? Now we come to the characteristics of these particles, okay, of a solution. Now what are the characteristics of a solution? See, a solution is, it's a clear and transparent substance, okay, where light can pass through without scattering. The solute particles can break down to molecular size. The solute particles that can be broken down into molecular size, which can be less or the size may be 10 to the power minus 9 in diameter, micron in diameter. Okay, now 10 to the power minus 9 in diameter, or it can be lesser, but the solid particles can be broken down. Okay, now it can completely pass through the filter paper. When we try to filter it out, we can see that the solution can completely pass through the filter paper. Is a homogeneous mixture. The solute particles do not settle at the bottom when it is at a constant temperature. When the temperature is constant, if we keep the solution for some time, we will see that no particle is settling down at the bottom of the container. The solute can be recovered by physical processes like evaporation or crystallization. From the solution, we can recover the solid particles by evaporation or crystallization. Next, we come to the characteristics of a suspension. See, here the size of the particles are slightly bigger. Okay, here the particle's diameter is 10 to the power minus 5 centimeter in diameter. Okay, and therefore it can be seen with unaided eye. Okay, The particles can be separated from the solvent by filtration process. Okay, and when we keep it for some time in the container, we will see the particles have sedimented, have settled down at the bottom of the container as sediment. Okay, it is a heterogeneous mixture in nature, and when light is passed through the suspension, light scatters very much, so path of light is not visible. Light scatters very much, and so the path of the light is not visible. See, you can see that when it is passing through the solution, the light is not scattering, but through when it is passing through the suspension, the light is scattering and we cannot see the path. Okay, next we come to characteristics of a colloid. Okay, now the size of the colloidal particles, we know it ranges from 10 to the power minus 10 micron to 10 to the power 10 micron, minus 10 micron. And the diameter ranges from 10 to the power minus 7 to 10 to the power minus 5 centimeter. Okay, the particles can be seen through powerful microscope. Okay, so solution particles not able to see. The suspension particles can be seen through unaided eye without any microscope, and the particles of this colloid that can be seen through a powerful microscope. Okay, excuse me. The particles do not settle down with time, so quite stable. It is quite stable because it does not settle down at the when it is kept undisturbed in the container. Okay, the particles cannot be separated by filtration because it can pass through the filter paper. They cannot be recovered by crystallization or evaporation. So filtration cannot separate them, crystallization, evaporation cannot separate them. Only they can be separated from the solution okay, by centrifugation. Okay, centrifugation is also a physical process by which butter and all those can be separated out from the solution. So centrifugation, by this process only the colloidal particles can be separated from the solution. They scatter light, but when strong beam of light is passed through the solution, the path becomes visible. Colloid is not transparent, but it is translucent. It's not transparent like the solution particles, ordinary solution particles, but colloidal solution is translucent. They are heterogeneous in nature. Okay. Next is water of crystallization. What is water of crystallization? It is the amount of water which is in a loose chemical combination with one molecule of a substance in its crystal form. Okay, so substance is there, and in that loosely water molecules are combined in a loose manner. Okay, you can always separate the water molecules from it. Okay, and that gives, when the water molecules combine with that substance, it forms a crystal form that is known as water of crystallization. That water which is present in the chemical forming a crystal form. Okay, that water is known as water of crystallization. The substances which contain water of crystallization are known as hydrated substances. For example, CuSO4 5H2O, hydrated copper sulfate, that is CuSO4 5H2O. So 5H2O is the water of crystallization which is present in the copper sulfate with the copper sulfate crystals. Okay, forming the sulfate crystals. The dot in the formula, that is CuSO4 dot 5H2O. So the dot in the formula indicates that the water molecules is in a loose chemical combination and can be removed by heating. If we heat it, we can always remove the this water of crystallization from the substance. Okay, as it is loosely held with the salt, it can be separated by heating up to a certain temperature, that is by 200 degrees centigrade. If we heat the substance, we can easily remove the water molecules from it and making it an amorphous solid, that is anhydrous powder. Okay, that is known as amorphous solid. Okay, a crystal is a, what is a crystal? It's a homogeneous solid of definite geometrical shape in which the particles are arranged symmetrically. Okay, it is a homogeneous solid which has a definite geometrical shape, either it's a square or rhombus, like that. It's a definite geometrical shape in which the particles are arranged symmetrically. Okay, the process by which crystals of a substance are separated by cooling its supersaturated solution is known as crystallization. Okay, so when a supersaturated solution is made, and when we that is hot, okay, and when we cool it, then crystals are formed. So by forming crystals separating out of the supersaturated solution, this is a process by which a solute can be obtained from a solution. So that is that process of forming crystals from a hot supersaturated solution is known as crystallization. Okay, now the substances which do not contain any water molecule is known as anhydrous substances. Hydrous means water, so anhydrous substances do not contain any water molecules. Maybe crystalline like sodium chloride, sugar, etc., or amorphous powder. So these anhydrous substances may be crystalline like sodium chloride, salt, that is common salt, then sugar. They are anhydrous substances, but they are in the form of crystals. Okay, then amorphous powder form, anhydrous substances that are in the amorphous powder form, that is calcium carbonate, zinc carbonate, copper oxide. These are all an amorphous powder form, anhydrous substances, and in the form of amorphous powder. Okay, now, substances which lose water of crystallization when exposed to air, they are known as efflorescent substances. Okay, when exposed to air, they lose their water of crystallization by natural process. So that phenomena of losing water when exposed to air is known as efflorescence. And the substances are efflorescent substances like washing soda, global salt, that is sodium sulfate, 10H2. That is also a efflorescent substance which loses water when exposed to air, and it becomes anhydrous. Now, the substances which absorb water when exposed to air, those are deliquescent substances, and the form phenomena is known as deliquescence. Okay, like caustic soda, sodium hydroxide, magnesium chloride, calcium chloride, ferric chloride. These all, they lose they absorb water from the air, and they become crystalline, and they become moist, and they are deliquescent substances. Now sodium chloride, note that sodium chloride is not deliquescent substances, but they absorb the moisture from the, especially during the rainy season, we see that sodium chloride becomes moist. Why? Because it contains magnesium chloride and calcium chloride as impurity, and those substances are deliquescent, and that's why it becomes moist. Substances which absorb moisture from the air without dissolving in it, those substances are hygroscopic substances. Absorb moisture from the air, but they do not dissolve in it. Those are hygroscopic substances, and the phenomena is hygroscopy. For example, sulfuric acid, phosphorus pentoxide, calcium oxide, silica gel. Okay, they are used as drying agent. Okay, note, silica gel are found in pouches which absorb the moisture, and they are kept to dry things, that is kept in shoe boxes, loose tablets, camera lenses. They are kept so that they can absorb the moisture from the substances, and the substance can be kept dry. So I stop here. I'll continue with the rest of the chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box, and do subscribe to get the notification of my next video. Okay, thank you for watching, and have a good day.